Now we will go through the next section, service or load balancer. So load balancer or service is used to provide networking to the deployment or acts as load balancer to the deployments. Service is used to add network to the deployed pods. In real definition, it's an abstraction to help you expose group of pods or deployments over a network. So service type. So coming to service type, we have three types of services. One is ClusterIP, NodePort, and load balancer. So ClusterIP is a default service type. So primarily used for internal communication within the cluster. Let's say you want to communicate, you want to establish communication between pods, then you go for the ClusterIP. Pods within a cluster, then you go for the ClusterIP mode of networking. Only accessible within the cluster network. You won't be able to access it outside of the cluster network. You basically can't access it from the local host or from outside the local host. So coming to IP assignment, it allocates a virtual IP within the cluster. You won't get external facing IP address when you're going with the cluster IP. So services that are only consumed by other services within the cluster. This is most important. Let's say there is a service that requests connection to database. Then the connection between the database might be exposing a cluster IP so that it can be only accessible within the cluster, not from outside. But at the same time, it can be accessed by the pod that is present in the cluster. Internal load balancing. So that's another use case of ClusterIP. So when you are seeing ClusterIP, this should be your primary thought. Like it's used for internal communication within the cluster or port to port communication. So ClusterIP will be like port to port communication, not for external communication. Port to port internal communication. This should be the thought that come into your mind. Port to port internal communication. NodePort exposes nodes in the cluster. So this is used when you want to access the service within the cluster as well as from outside the cluster through a port. So allocate static port on each node. And so the use case of NodePort is services that needs to be accessed from outside the cluster but do not require a public IP address. So it's an example of simple load balancing. So you will get an internal IP address, but you won't be getting a public IP address, but you will be able to access it from outside the cluster. In our demos we will be going with NodePort because this is localhost access. So whenever you are seeing NodePort, the first thing that should come into your mind is localhost access, and NodePort is used for testing primarily. So and the services can be accessed from outside, but most likely for testing purposes. And next thing is load balancing. So load balancing is an enterprise setting of services. So the purpose is to expose service to network or expose service to internet or a corporate network. IP assignment, when it comes to IP, creates a load balancer in the cloud provider's infrastructure and assigns a public IP. In load balancer setting, you will get a public IP and you can access the service from anywhere in the world. So the use case is services that need to be publicly accessible. So let's say we have Netflix.com, so it will hit the load balancer service first. Then the request gets internally routed to the deployment or the pod. So advanced load balancing features like affinity, session affinity, health checks. So load balancer is an advanced setting and you will be using load balancer in enterprise grade settings. So to show you a demo of the services, so we will be going with NodePort because we can access it from the NodePort or from the localhost, and this is mostly used for the testing purpose, or simple deployment you go for the NodePort. This is not the preferred way of deployment due to security concerns. Still, for testing, this is a variant of services in Kubernetes. So we'll, as usual, we'll go and search for the services in Kubernetes. And so services, we'll search for service.yaml example in Kubernetes, and we will get service documentation. So here you go, you copy the first available template, copy it, come back to the terminal. So terminal will create a service.yaml file. Paste it here. So here we will go through the important parameters. One is a kind is of service, and you specify the name as my service. Here you are providing a selector. You have seen the selector, right? This selector should be same as the template label that you provided in deployment. So let me do one thing. Let me cat deployment.yaml file. So here the template label is app nginx. So this should be matching to the service selector. So let me deploy this deployment -f deployments.yaml. So it created the deployment. This is a label app nginx vi, and the name is service.yaml. I didn't create a file. Service.yaml, copy it, paste. So kind is service, name of service is my service, and let me change the selector. Selector is app nginx, and I'm specifying protocol TCP 80, and target protocol is, let me check one more second, app nginx. This label should match service.yaml selector app nginx. So that is same. Next thing, what we need is a NodePort. So we'll be searching for NodePort. You can see NodePort example. We need to copy this field. What you need to do additionally is, okay, instead of this, let me remove the service.yaml. vi service.yaml. Let me copy this. So service, the selector is app nginx. The type of service is NodePort. So app nginx. The port that the container is running is 80. The target port is 80, and the port that you want to expose. The port that you want to expose to the local host is provided in NodePort. So it will be exposing to the port 30,007, and it should be in the range of 30,000 to 32,767. So you save it. So we'll again go through the service.yaml file. Kind is service. You provide the name of service. You specify the type of service as NodePort, which is localhost, nothing but localhost. Selector as app nginx. This should be same as the one that is present in the deployment.yaml file, and you specify which port it should be looking for and which port it should target to, and the NodePort to which it should be accessible from the localhost. So here the localhost is accessible from 30,007. So let's save it and kubectl apply -f service.yaml file. You start the service. So kubectl get service can be also called as svc. So you can see there is my service and the node is of type NodePort and the cluster IP is 10.43.9.175 and it is exposing the port 30,007 to the local host. Now you can see that the service is running on the port 80 and 30,007. Since we are running in K3D, you need to do an additional step that is port forwarding. So let's do the port forwarding. This is a command to do the port forwarding. Here we are forwarding my service running on port 80 to 8082. So if you do this step, the ports whatever request is coming on port 8082 will be forwarded to port 80 inside the cluster. So let's paste it. So it's already forwarding now. Whatever comes to 8082 will be forwarded to 80 inside the cluster. So let me run localhost 8082. You can see it is serving the page nginx, and this is coming from the deployed service. So that's one, and let's stop it. Now let's see how to access nginx from another deployment or another service. So let's copy this. So I'll create one Ubuntu deployment. So ubuntu.yaml, and I'll paste the content here. So I'll create an Ubuntu deployment, Ubuntu container, and let kubectl apply -f and ubuntu.yaml. So it creates a ubuntu.yaml file, creates Ubuntu deployment. Now let's get into the Ubuntu pod. So you can see there is one Ubuntu pod. So let's get into it, exec into it. So exec ti Ubuntu deployment, and let me bash into it, Ubuntu deployment and bash. So clear. So once I do env, you can see my port information is already present inside or already injected into this container. My service port, my service TCP protocol, my service load balancer address. So let's do one thing. Let's do curl of my service. Okay, curl is not installed on this container. So what we need to do is apt update. Wait, apt install curl -y. And now let me do curl my service. You can see it is able to connect to the nginx and retrieve the HTML file. So you can access other services from the deployments too. So all this works because of the internal load balancing that we mentioned before. That's it with the services. That's how you connect from one service to another service, or connect from one deployment, one port to another service. And this is how we do the port forwarding. Yeah, thank you.